Hello again. In this chapter, I want to cover another potentially useful topic called filters. In my experience, these are actually most useful when you're in the process of building a web application for the purposes of debugging, but there are other potential uses in production environments also. So far, what we've seen is that when a user requests a servlet from the server, then a method called either service, doGet, or doPost is run. These methods all take two parameters, a request object and a response object. Within the body of the servlet's method, we can query the request object to find out about the client, for example, any parameters that were sent to the method, and if it has a session cookie. And then we use the response object to compose a response back to the client. That's where we set the header information and the HTML content. A filter lets us intercept this process at the point before the servlet runs. We can think of it as providing a diversion. Let's imagine we're calling a particular URL. This URL mapping is assigned to a servlet in our application. But we've also built a filter and we've given that filter the same URL mapping. What then happens is that our application will route the incoming request to the filter rather than the servlet. In the filter, we can inspect the request and response objects, and if we like, we can change their contents. Then when we're done, we can choose whether to send this request to the original servlet that the user requested, or to another place of our choosing. The servlet can then continue its normal processing, potentially using our adjusted request and response objects. In my experience, the most common use of a filter is actually to add to the logging of our application, and we'll create a filter in this chapter that does just that. What we'll build is something that logs every time a search is performed. We'll store in our log what parameters the users are searching for. That might be useful for us over time, as it will tell us what our customers look for most in our menu. But because we're going to write this as a filter, it means that we are not touching in any way the servlet code that we've written. I think it's quite nice to do things in a filter independent of the servlet because it gives us the power to switch the filter on or off very easily without having to adjust any of our servlet code. And because this is really a completely separate task, this logging idea, we don't have to complicate our servlet by having extra code in there, which is really nothing to do with the processing of the search request. So let's have a go at doing this in our project. Now, I like to put the filters in a separate package, so we'll start by creating the new class, and we'll put it in a package called com.virtualpairprogrammers.filters, and we'll call this first one, well, it's going to be logging our searches, so I think we'll call this menu search logging filter. Now, it needs to implement an interface, and the interface is called filter, so let's find that. There's a few of these, so you need to make sure you pick the one from the javax.servlet package, and we'll make sure that the default method stubs are created for us. So the filter has three methods called init, doFilter, and destroy. The init method is like a constructor, and destroy is called, well, it's called either when all the threads that the web server is using to do with this filter are unloaded, or after a timeout. I actually think it's so difficult to predict when destroy will actually be called that it's better not to use that method. But unfortunately, it is a mandatory override, so we have to have an empty destroy method in all of our filters. Actually, I don't tend to use the init method either. In theory, you could open resources in the init method and close them in destroy. I think it's just safer to do everything in the doFilter method. So in here is where we're going to be doing the work. But before we start writing any code in here, the one thing that's important, of course, is to say which servlets is this filter going to be running against. It can actually run against multiple servlets, and we do that with an annotation. If you remember, we configure our annotations with the @webServlet annotation, while we configure filters with the @webFilter annotation. And this attribute, just like Web Servlet, can take the URL as a parameter. So we want it to work on the same URL as our search servlet, which is this one here. So the URL is searchresults.html. In fact, I think I'll copy that and paste it into our new filter, which is this one here. So we'll need to import the @WebFilter annotation. But now what should happen is that whenever our browser is sent to searchresults.html, the web server will first run the filter and then it'll run the menu search servlet. Actually, we'll talk about how it knows to run that servlet in a minute or two. Before we do that, there's just one other thing I want to point out, which is that if you wanted to run this filter on multiple servlets, you can do that. We just need to provide the parameter in a slightly different format. And that is, we put in value equals, and then in curly brackets, a list of the parameter names. So we could have something like another URL here. I'll close my curly brackets just to make sure that will compile. And now this filter would work both on search results and on the other URL as well. So I'm going to leave in this structure just so you can see it, but you can use Web Filter just with a single parameter. And in fact, we'll create another filter and do that in a few moments, just so we've got an example of that as well. Okay, so our doFilter method then, which is where the work's going to happen. As you can see, it takes 3 arguments. Now I'm going to rename these to make them more meaningful than arg0, arg1. So the request object we'll call request. The response object we'll call response. And this filter chain is actually the object that's going to allow us to say, now go and do the processing of our servlet. So we'll call that one chain, and we'll see how we use that in just a moment. But before we do that, now we want to do our logging code. Well, I'm just going to print out to the console. Obviously, if this was a production system and we had a production logging system in here, we would simply be calling methods on the logging implementation. We don't have that, and we don't need it to learn about web. So what we'll do is simply a system out print line. So let's get the parameter that the user searched for from the request object. I can copy that, I think, from the menu search servlet. Yes, it's this line here, look. The search term is the parameter search term. So let's copy that, paste that into our filter. And then now we know the search term, we can write it to our log. So we'll do a system out print line. And we'll put user searched for : and we'll add on the search term. Okay, so that should take care of the logging code. And now we want to run the original servlet, and we do that by calling chain.doFilter, and we need to pass in a request and a response object, which is the objects we've got here, request and response. It's called doFilter because actually you could have multiple filters on a single servlet, and what this would mean is call the next filter in the chain, and then when all the filters have been called, it would call the servlet. We'll go and have another look at this. We'll create a second filter in a minute or two, but before we do that, that should be enough for this filter to do the logging, so let's try it out and see if it works. So we'll make sure everything is saved, and we'll stop and restart the project. So I'm going to just make my window a bit smaller so we can see the console at the bottom here. Let's start from the home page. And well, I think we'll do a search actually then. So from search.html, and let's search first of all for veg, short for vegetables. Great, so my search has happened. I've got my results. And down here in the console, we can see that the logging worked as well. From the home page, you might remember we have a link to view all of our chicken dishes, which also works using the same search system. So if I click on that, I should see chicken in my log as well. Let's try it and see. Yes, there's chicken in the log, so that looks good. So that's a simple filter which allows us to inspect the value of the request object. However, we can also change values in the request object within a filter. It's a little bit more complicated, but we'll have a go at doing it because it might be something that's useful for you. And also by doing that, we'll be able to demonstrate that you can have multiple filters acting on the same URL. So what I think we'll do is create a second filter, and in this filter we'll have a look at the search term and we'll potentially change its value. Now we need a use case for this, so I'm going to pretend that this restaurant is going to be set up in Australia. And in Australia, it's quite common for chickens to be called chooks. Now, I hope I'm not offending anybody watching this video with that phrase. It's something I learned as a child by watching some pretty dreadful Australian television programs. But what I think we'll do is we'll check to see if the user searched for chook, and if they did, we'll change the search term to chicken. So we'll correct, if you like, a slang term for a chicken to the real phrase for a chicken. That's what we're going to do in our new filter. So let's go and create the second filter as a starting point. So again, we'll put it in our filters package, which is here. And I think we'll call this one menu search correction filter. So we're correcting the search term if the user puts in an unusual word. Let's add in the filter interface and click on finish. What we'll do is start by extracting the search term again, which we can do as we've done before by calling request.parameter search term. Actually, I'll need to rename my attributes here to request, response, and chain. Okay, so we've got the search term. What I want to do is something like if the search term equals chook, and I think just to be on the safe side, we'll do it to lowercase, and then we can do our equals, and it's going to be CHOOK. I think that's the right spelling. What we'd like to do in here is change the value of our search term. Now, this is where things start to get a little bit complicated. Ideally, we want to do something like request.setParameter and the value of search term, but unfortunately, setParameter is not a method on the request object. That has been done on purpose because the Servlet API specification says that you shouldn't be overriding the values that are set by the user. It's a way of, if you like, preserving the integrity of the data that's being sent to our server. But there is a way we can do it. And that is, we're going to be creating a different type of object, which is called an HTTP Servlet request wrapper. If you're familiar with the decorator design pattern, then what we're about to see might look quite straightforward, but if you're not, don't worry. The idea is we're going to create a new type of object called this request wrapper, which is going to wrap a request object inside itself. So what we're going to do is start with our request object. We're going to create the new request wrapper, which is going to contain our request object. And, well, the default at this point is that if we try and call a method on the wrapper, it will delegate down to our request object to get the values. But we can also create our own state values, our own methods at the wrapper level, and override the servlet request methods. So what we can do here is we can say, if the method here is a certain method, delegate it back down to the request object. But if it's a particular method that we're interested in, don't delegate it, instead do something different. And that way we'll be able to override the search term parameter. Now, don't worry if that doesn't make any sense, as we're about to see the code isn't that difficult, and hopefully when we've written the code, it will make sense. So what we're going to need to do is to start with a new object. So it's going to be an object which I think we'll call menu search correction request wrapper. Now this is going to extend the HTTP Servlet request wrapper object. So let's change our superclass to that. So we'll need to search for HTTP Servlet request wrapper. Here it is. And we'll click on finish. Now, as a minimum, you must provide a constructor for this object, and I think we'll get Eclipse to do that for us. So let's click on the Add Constructor option here. And the constructor is required to take a request object as a parameter, and it calls the super on request. So that's all okay. And actually, for our purposes, there's nothing further we need to do on the constructor. But what I do want to do is I want to override the getParameter method. So we're going to have something like public string get parameter, and that takes the name of the parameter as an input, which I think we'll call key. So we're going to do something in here, and I want to make sure this is overriding a method of the HTTP Servlet Request Wrapper class. So let's put the @override annotation on there as well. Okay, well in here what we can do then is we can say if the key that we're looking for is our search term, then do something different. Otherwise, we can just delegate to the HTTP Servlet request. So it'll be something like if our key equals the words search term, then we're going to do something in here. Otherwise, we want to return the search term from our request object, which we can do by calling super.getParameter. And the parameter is our key, and that should work. So now we've been able to intercept the request object and say if they're looking for the search term, return something special. Otherwise, just carry on and do what you would have done anyway. So we'll need to somehow get our new search term into this class. So let's create a private variable to store it. I think we're going to need a setter method to be able to set that value. So let's create one of those. Okay, now in our getParameter method, we can return the new search term. So I hope that makes sense. What we've created here is an extension, if you like, of our original HTTP Servlet Request object, which contains it, and by default, anything that we try and do with our extension is going to delegate down to the underlying request object, unless we try and call getParameter. And if we get parameter on the search term, then what we're going to get back is our search term. Otherwise, it's going to delegate to that higher level request object. So now we've got this, we can use it in our filter. So back to the filter then. And what we want to do in here is create a new instance, first of all, of our menu search correction request wrapper. I do like to use long class names just because then it's obvious what's going on here, but I think we'll call it wrapper. So let's have menu search correction request wrapper, which we'll call wrapper, and we'll set that equal to a new menu search correction request wrapper. Now, by default then, the constructor requires an object of type HTTP Servlet Request. You might have noticed that this method is taking a servlet request object. Now, I have no idea why this is the case, why by default a filter expects a servlet request rather than an HTTP servlet request. I guess it's because you could probably apply filters to things other than servlets, but it does add an extra, not that major layer of complication, but it does add an extra bit of complication for us. The HTTP Servlet Request object is a subclass of Servlet Request, which means that we can cast this request object into an object of the required type. So in here, what I can do is hopefully cast request into an HTTP Servlet Request. So I think we'll probably need to import HTTP Servlet Request. And now hopefully that line of code is going to compile. So that's created the wrapper object. Now that we've got our wrapper object, we can call its set search term method. I think it was set new search term actually. Yes, it was. And our new search term then is going to be the word chicken, because that's the idea here. We're going to remove chook and replace it with chicken. And then we want to do our filter chain processing. So we're going to call chain.doFilter. And we need to pass in a request and a response. Well, the request this time is our new wrapper object, but the response is the original response object, and that should do the work. Now that deals with the if case where the search term was the word chook. If the search term was anything else, well, we can then just carry on the processing without doing anything different. So down here, we can have an else chain.doFilter, and here we'll pass on the original request object and the response object. So there's one last step we need to do, which is we need to give this filter a URL, and it's going to be the same URL as our menu search servlet. So I'm just going to copy that part and add in here at web filter and the value of search results. Just make sure web filters are imported, and that looks like it's going to compile. So what we've now got then in our project are two filters on the search results URL, the menu search correction filter and the search logging filter, and we've got a servlet on that URL as well. So when we now try and do a search, both of these filters are going to run before the servlet. We have no way as developers of dictating which filter runs in which order. So we'll try it now and see what happens, but it's important that when you write your filters, there's no way of saying run this filter first and then that filter. But we'll see what happens. Let's give it a go. So we'll start the application up. We'll go to the search page. And I think we'll search for something else first of all. Let's search for veg. Okay, well, we've got our results and we can see the user searched for veg. Let's search for chook now. Okay, well, you can see down here we logged that the user searched for chicken. So that tells us that our correction filter ran before the logging filter, and clearly the correction filter has worked. It's changed our value of chook into chicken. What's interesting, you might notice, is that the URL still says chook, but our correction must have worked because nowhere in this line is the word chook. So it's definitely done a search against the word chicken. So doing filters either to inspect or to change values in the request object is not too difficult. And one quite nice thing is that they're very easy to switch off. You simply remove the @WebFilter annotation. Let's just switch off the correction filter, run this again, and we'll search for chook. I think I can just refresh this page. Well, we can see we get no dishes containing chook, and we got chook logged because we've switched off the filter. I think I'll switch it back on for the purposes of the closing workspace, but that's filters, quite useful functionality and not too difficult to do. The next two chapters are going to look at something a bit different, which is a much better way of writing our servlets using a technology called Java Server Pages, or JSP. So take a break if you need it, and when you're ready, I'll see you in Chapter 3.